Let's go ahead and continue looking at these 2x2 systems and application problems. So in the last video, we looked at a couple different applications. In this video, we're just going to look at a few more, give you a little bit more practice setting up these systems and solving them. All right, so let's go ahead and start with example 3. So this is asking us how many liters of a 9% solution of salt should be added to how many liters of a 16% solution in order to obtain 350 liters of a 12% solution. Okay, so as usual, we need to start by defining our variables. So we need to figure out what we want to call x and what we want to call y. So based on the question that we're being asked here, how many liters of the 9% solution and how many liters of the 16% solution, that's how we're going to want to define our x and y. So I'm going to let x equal liters of the 9% solution, and I'm going to let y equal liters of the 16% solution. Okay. All right, next we need to build our system. So if we read what we're given here, we basically have two different things that we're looking at. We have the liters, okay, we know that we're adding X liters to Y liters to get 350 liters. And the other thing we have is the percent concentration. We're adding a 9% solution to a 16% solution in order to obtain a 12% solution. So these are going to be our two different equations that we're looking at. So let's go ahead and let's start with the percent concentration. So we are looking at adding let's just say X liters of a 9% solution to Y liters of a 16% solution for a total of 350 liters of a 12% solution. So if we put that together, just remember that whenever you hear that word of in math, you're thinking multiplication. So X liters of a 9% solution is just 0.09x, and then Y liters of a 16% solution, 0.16y, and then we want this to equal 350 liters of a 12% solution. So that would be 0.12 times 350. All right, so that's our first equation. That's dealing with that percent concentration. The second equation is just going to be dealing with the total volume, the total number of liters. And for that, we just know we're adding X liters to Y liters for a total of 350 liters. All right, so those are our two equations. So now we just need to solve it, and we can use substitution or elimination. Technically, you could graph it as well, but I find that to typically be a little bit more work than it's worth. So I think the last two problems I did substitution for, so I'm going to go ahead and do elimination on this one, just to kind of mix it up a little bit. And if we're trying to eliminate, remember the goal here is to get either our x's or our y's so that when we add the two equations together, they'll cancel out. Now looking at it right now, nothing's going to cancel. So we're going to have to do some multiplication. So I'm going to go ahead and I'm going to focus on my x's. So looking at the top equation, we have a 0.09. So if we want to eliminate the x, we would need the bottom equation to be a negative 0.09, just the exact opposite. So I'm going to go ahead and just multiply that bottom equation through by a negative 0.09. And if we rewrite this, the only thing to do in that top equation is just to simplify the 0.12 times 350. That's just 42. And then the bottom equation, go ahead and multiply through that negative 0.09. Okay, so if we multiply that negative 0.09 through, this is what we're going to get. All right, now add your equations up. So of course, if we add them up, our x's cancel. That's how we designed it to work. And then if we add up our y's, we would get 0.07y. and then the 42 and the negative 31.5 is going to give us 10.5. Okay. All right, and then if we go ahead and divide the 10.5 by 0.07, we get 150. So y is equal to 150. And remember, y was liters of the 16% solution. So 150 liters of the 16% solution. All right, and then the last thing we need to do is just back substitute in order to solve for x. And we can plug it into either equations 1 or 2. Either one will give us the same answer. I think equation 2 looks a little bit easier to work with though. So I'm going to go ahead and just plug this back into equation 2. So x plus 150 is equal to 350. And then just subtract the 150 over, and we'll get x is equal to 200. Just going back up, that was liters of the 9% solution. So 200 liters of the 9% solution. All right, so those are our answers. So we're combining 200 liters of a 9% solution with 150 liters of a 16% solution in order to get 350 liters of the 12% solution. All right, let's go ahead and do one more example. Oops. Forget you saw that. It wasn't there. Okay. All right. So example 4. All right, so it says Trisha received an inheritance of $5,500. She invested part of it at 8% simple interest and the remainder at 12% simple interest. All right, so we have $5,500. She's investing part of it at 8% and part of it at 12%. All right, and then we also know that at the end of the year, she had earned $540. Okay, so that's how much she earned in interest. And then our question is how much did Trisha invest at each interest amount? Okay. All right, so as usual, we're going to start by defining our variables. So what we're being asked on this one is how much did she invest at each interest amount? And our two interest amounts are the 8% and the 12%. So I'm going to go ahead and let x equal the amount invested at 8%. And I'm going to let y equal the amount invested at 12%, okay? Because those are the two things that we're trying to find on this one. All right, then we want to build our system. So if we read through what we have, okay, the two things that are being discussed on this one are the total amount of money that she's investing and the total amount of interest that's being earned. So let's just start with the investment. We know that she's investing X dollars at 8%, she's investing Y dollars at 12%, and she has a total of $5,500 to invest. So that would be X plus Y is equal to 5,500. Okay, so the two amounts that are being invested for the total of the $5,500. All right, now the other thing then is the interest that's being earned. So we have X dollars invested at 8%, Y dollars invested at 12%, for a total of $540 at the end of the year. So if we put that together, we'd have 0.08x plus 0.12y is equal to 540. All right, so we have our system. Now we solve it, okay? So again, we can use substitution or elimination, whichever one you prefer. I'm going to do elimination again just to get a little bit more practice with that method. So if we want to use elimination, We can choose to either eliminate the x or the y. I'll go ahead and just do x because that's first. So with our 0.08x in the bottom equation, if we wanted to eliminate that, we would need a negative 0.08x in the top equation. So we'll just multiply through by a negative 0.08. Okay, so then our new equation, if we multiply that through, we'd have negative 0.08x minus 0.08y, and then the 5,500 times negative 0.08 is negative 440. In the bottom equation, we didn't change anything on, so just copy that down. All right, so now add up our equations. As designed, the x's cancel. And then if we add up our y's, we're going to get 0.04y. The negative 440 plus the 540 gives us 100. And then divide both sides by the 0.04, and we'll end up with 2,500 as our y. Now going back up at our to look at our variables, we said that y was the amount invested at 12%. So this is $2,500 invested at y was 12%. All right, and then just plug this back in, and you can plug it into either equation 1 or 2. I think 1 looks a little bit easier. So we'll have x plus 2,500 is equal to 5,500. And if we subtract the 2,500 over, we get $3,000 invested at 8%. So that's our solution. $3,000 invested at 8% and $2,500 invested at 12%. All right, guys, so there is one more example if you look at the notes that I posted on Blackboard. So try and go through that example on your own. Check the notes as just a reference to make sure you're doing it right. And if you have any questions on anything, as always, just send me an email.